Hello, welcome to MATLAB video series, Chapter 6, Programming in MATLAB. A computer program is a sequence of commands. In a simple program, the commands are executed in the order they are typed. But in a sophisticated program, we can skip some commands and run it with different input variables. MATLAB provides several tools that can be used to control the flow of the program. They are the conditional statements, switch structure, for and while loops. Now, to change the flow of the program, it requires a decision process within the program, which is possible by using the two kinds of operators, relational and logical operators. Relational operators. Compare two numbers by determining whether a comparison is true or false. If true, it is assigned a value 1. If false, it is assigned a value 0. Here is a list of relational operators: less than, greater than, less than or equal to, greater than or equal to, double equal to, and not equal to. Equal to relational operator consists of two equal signs with no space between them, since one equal sign is the assignment operator. Relational operators are used as arithmetic operators within mathematical expressions. The result can be used in other mathematical operations. Let's look at some of the ways in which you can use relational operator. Two numbers are compared. So for example, 7 is less than 6. It's a logically false statement, so the answer is 0. -7 greater than -10. It is true statement, so we get 1. We can also use relational operators to compare two arrays. We'll get an array of 1s and 0s. So here A and B are two vectors. You're comparing them using A greater than or equal to B. Scalar can be compared with an array. Then each number is compared with every other number in the array. So C equal 3 and D equal 3, -3, 0, C double equal D. So this 3 is compared with the first element in D, which is 3, so the answer is 1. Then again this 3 is compared with -3, so it is 0, because they are not equal. And the 3 is compared with the last element 0, they are not equal, so the answer is 0. Similarly with an array. 5, 6, 7, 1 is a 2 by 2 matrix. It's compared with the scalar C, and you get the following array with 0s and 1s. Order of precedence. In mathematical operations, it includes relational and arithmetic operations. Arithmetic operations have higher precedence. Let's look at this example. 2 plus 3 less than 14 over 2. So here the arithmetic operation is plus and a division. So these will be executed first. So 5 less than 7, which is a true statement. So the answer is 1. In the second example, we have modified the priorities using brackets. So 7 greater than 2 is executed first, which is logically true. So it is 1. And then 1 divided by 4 is subtracted from 6. So the answer would be 5.75. Now we learn a new function called the find command. Find x. It computes an array containing the indices of the non-zero elements of the numeric array x. For example, x is -204. Find x gives the indices where you have a non-zero number. So -2 is in position 1 and 4 is in position 3. Let's use the find function for another scenario. X such that x less than y. Here x and y are two vectors, and we get the x values where the x is less than the y. But if we use the find function for x less than y, it gives the index numbers where x is less than y, which is in position 1 and position 4. Next we come to logical operators. We have basically three logical operators here: the AND, OR, which is using the straight line, and NOT, which is using the tilde. So you can either use AND, AND, OR, NOT, or use these symbols. Logical operators have numbers as operands. A non-zero number is true and a zero number is false. Logical operators can be used as arithmetic operators within a mathematical expression. They can be used with scalars and arrays. The logical operators AND and OR can have both operands as scalars, arrays, or one array and one scalar. The logical operation NOT has one operand. When it is used with a scalar, the outcome is a scalar 0 or 1. When it is used with an array, the outcome is an array of the same size with ones in positions where the array has non-zero number and zeros in positions where the array has zeros. This is a truth table. According to the order of priority, always NOT has the highest priority, then and the least priority is for OR. NOT, as we know, has only a single operand, so NOT of X, so true becomes false and false becomes true. X and Y, we notice that we get false if either of the X and Y is false, but we get true only if both are true. And the last operator, which is the OR, X or Y, we get true if either of the inputs are true, and false only if both are false. This is the order of precedence when we have parenthesis, which is always having the first priority, then exponentiation or any other functions, logical NOT, multiplication division, addition subtraction, relational operators, logical AND, and logical OR. Let's look at this example. X has a value -3 and Y has a value 7. So -6 less than X less than -1. This statement is correct mathematically, but Matlab evaluates it as 0, which is wrong. So how do we correct this error? We can introduce the logical operator AND. So -6 less than X and X less than -1. So here -6 is compared with -3. So the answer is 1. And 1 and X is here -3. So -3 less than -1. That is also a true statement. So 1 and 1, you get 1. But why do you get 0 here? That's because it is executed from left to right. -6 less than -3. It's true. So the answer is 1, and 1 less than -1 is false, so the answer is 0. And the remaining examples, you can pause the slide and go through them. Let's move on to conditional statements. A conditional statement is a command that allows Matlab to make a decision of whether to execute a group of commands that follow the conditional statement or to skip these commands. These are the different ways in which you can use conditional statements, but all these variables should be predefined. Conditional statements can be a part of the script file or the function file. The if statement is used in 3 structures. If you have only one condition, if end, 2 conditions, if else end, 3 conditions, if else end. This is the basic structure of the if end structure. Then if else, so if, then you write the condition 1 and the block of statements to follow that. Else, condition 2, another set of statements, and then you end it. But if you have 3 conditions, you'll continue with else if in between. Conditional statements are logical expressions that control the operation of the if construct. If conditional statement is true, it returns 1. When it is non-zero, then the program executes the expressions in the first block and skips to the end. Otherwise, the program checks for the result of conditional statement 2. If it is true, then the program executes the expressions in the second block and skips to the end. If all conditional statements return 0, that is false, then the program executes the expressions in block associated with the else clause. There can be any number of else if clauses, that is 0 or more, in an if construct, but there can be at most one else clause. Let's look at an example. Write a MATLAB program to display the type of solution for a quadratic equation. Prompt the user to enter the values. So we can prompt the user using the input commands. Then the type of solution depends on discriminant, which is d, so calculate that, which is b square minus 4ac. And we have three conditions. If d is greater than 0, display the equation has two distinct real roots. Else if d double equals 0, which means you're checking if d has a value 0. And if so, you display that the equation has two identical real roots. And last condition, it's already understood, which is for d less than 0, you do not have to mention that. So just write display the equation has two complex roots and then end. This is an example for writing a code that reads in a numerical grade and assigns a letter grade according to this policy. So the grade greater than 95 is A, between 86 and 95 is B, where 95 is included, so on and so forth. So let's start with grade, which is 80, but you can make it user specific using the input command. If grade is greater than 95, display the grade as A. Else if grade is less than or equal to 95 and grade greater than 86, display the grade as B, so on and so forth. So you can put in all the conditions using the else if command, and in the end you will use only the else. The switch case structure. The switch construct is another form of branching construct. It selects a particular code block to execute based on the value of a single integer, character, or logical expression. The general form of a switch construct is as follows. You have switch, the expression, and case, which is case expression 1, and then statements following that, case expression 2, statements following that, and otherwise, which is optional, and the statements following that, and the end. The expressions can be a string, a scalar, or a mathematical expression with predefined variables. The value of the switch expression in the switch command is compared with the values that are next to each of the case statements. If a match is found, the group of commands that follow the case statement with the match are executed. If there is more than one match, only the first matching case is executed. If no match is found, we skip to the otherwise statement if it is present. Switch for multiple cases. So we have switch and then the expression. Case, we address all the cases here, and then the statements to follow, which is the block 1, then otherwise statements follow, and block n. At most one code block can be executed. If the switch expression matches more than one case, the first one is executed. Use the switch case structure for the following. Prompt the user to input the following strings: triangle, square, pentagon, or hexagon. Depending on the figure which you input, the program will calculate the sum of the interior angles of the figure using this formula. So start with n, which refers to the number of sides of the figure. Input, please input the figure. Notice that we are using the letter S, which stands for a string, because the user will be inputting the name of the figure, which is a string. So the switching is happening for n. Switch n, case, we put the string, triangle, then if there is a match, the n has to switch to 3. Similarly, square, so n will be 4, pentagon, n is 5, case hexagon, n is 6. Otherwise, that is if there is a typo or any other value is put in for n, you display out of range, and then you can use the break statement and finally calculate sum using the formula n minus 2 times 180. So if the person is putting the value for n as triangle, then there is a match between the switch expression and the case expression, and n will switch to 3, and it'll skip all these and calculate the value of the sum. Write a MATLAB program that asks the user to input a number between 1 and 10, checks if it is an integer, and displays whether it is an odd integer or even integer or out of range. N equals input, enter the number. If n not equal to floor of n. Now, what does the floor command do? If we have floor of 3.5, the answer is 3. It rounds towards 0. So, n not equal to floor of n, which means 3.5, is not equal to 3. It indicates that n is not an integer. So that's why we are using this expression here. So if n not equal to floor of n, display not an integer, else switch n. The cases are 1, 3, 5, 7, 9, display its odd integer. Next case set would be 2, 4, 6, 8, 10, display even integer. Otherwise display out of range, and then the end for the switch and the last end is for the if structure. Loops. Loops are MATLAB constructs that permit us to execute a sequence of commands more than once. MATLAB has two kinds of loops, the for end loops and the while end loops. In the for end loops, you have the number of passes specified. In while end loop, the number of passes is unknown, but loop executes till a condition is satisfied. For k equal fst. So the first value of k would be f, the next value would be f plus s, and the last value would be t, with increment of s every time. The while end loop, we have while and a condition, and then a list of statements in between if the condition is true, and then the end. Break and continue. When do we use the break and continue statements in MATLAB? Break. If we use break inside a loop, it terminates the execution of the loop, that is the whole loop, and it jumps to the end command. If you use it inside a nested loop, only the nested loop is terminated. But if it's outside a loop, it terminates the execution of the file, such as when data transfer is not consistent with what is expected. Examples: if the number of loops exceeds a predetermined value, or error in a numerical procedure is smaller than a predetermined value. The break command is usually used within a conditional statement. The continue command can be used inside a loop, that is the for or while, to stop the present pass and start the next pass in the looping process. The continue command is usually a part of a conditional statement. When MATLAB reaches the continue command, it does not execute the remaining commands in the loop, but skips to the end command of the loop and then starts a new pass. Let's look at these two examples. First one is using the break statement. Print all the numbers between 1 and 10 except 6, 7, 8, 9, and 10. So let's look at the example here. Initialize the number a underscore num to 1. While a underscore num is less than 10, if a num double equal 5, a num equal a num plus 1, and then break end. So the first value of a num is 1. 1 is less than 10, so the statements below it would be executed. But if a num double equal 5, which means is 1 equal to 5? No. So it'll skip and come out of the end, and a num will become 1 plus 1, 2. So we already have 1 printed and then 2. Now is 2 less than 10? Yes. But is 2 double equal 5? No. So we'll skip all that, and the next value of enum would be 2 plus 1, 3. Next, 3 is less than 10, and 3 is not equal to 5, skip, and enum will become 4. Now, 4 is less than 10, 4 double equal 5 is false, so enum will become 5. 5 is less than 10, and 5 double equal 5, yes, it's true, so enum will become 5 plus 1, 6. But there is a break statement after that. That means it will break out of this if-and structure. So the values that will be printed are, let's run this, 1, 2, 3, 4, and 5. So it's not printing 6, 7, 8, 9, and 10 because it breaks completely out of that loop. In the second question, you have to print all the numbers between 1 and 10 except 6. So how does that look? Enum is initialized to 1. Is 1 less than 10? Yes. Is 1 double equal 5? No. So we'll skip all that, and enum will become 2. Again, 2 is less than 10, but it doesn't satisfy in between, so 2 will become 3. 3 is less than 10, and then 3 will become 4. 4 is less than 10, similarly 5, 6. But when it goes to 5, is 5 less than 10? Yes. 5 double equal 5? True. And enum will become 6. But it says continue. That means it will just go to the next pass, which would be 7. So 6 plus 1, 7 would be printed. Let's run this. So after 5, we have 7, 8, 9, and 10. Example 1. Square every element in this vector x equal 11 to 15. So we define x as 11 to 15 with increment of 1 for I equal 1 to 5. So I is the counter. X of I becomes x of I square. So the first value of the counter is 1. So x of 1 would be x of 1 square, which is 11 square, 121. Next I value will be 2. So x of 2 would be 12 square, which is 144. Similarly, 13 square, 14 square, and 15 square. So I value will change from 1 till it reaches 5. Next example, for k equal 20 with decrement of -1 till 10, display the value of k. So all the values of k starting with 20 with the decrement of 1 would be displayed, and it will end at 10. Next one, for k equal 1 with increment of 3 till 20. So all values of k from 1 with increment of 3 and with any value of k less than 20 would display hello. Some notes for the use of the for loop. You cannot change the value of the loop index in between. For example, in this case, I is going from 1 till 10 with increment of 2, and in between you cannot change the I to 6. Another interesting application is the element-wise operations. For instance, I equal 11 to 15, that is from the first example. You can square every element using the dot operator instead of using the for loop. So in fact, the element-wise operations is faster than using a for loop. Find the sum of all elements in a row vector. So you define the row vector using the input command. Then find the number of elements using the length command, which is stored in n. Define the sum to be 0. For I equal 1 till n, which is the number of elements in x, s will be s plus x of I. So the s is initialized to 0. The first value of I will be 1. So the new value of s would be s plus x of 1, that is 0 plus x of 1, which is 11. So s will become 11. Now I will be changed to 2, so s will be 11 plus x of 2. What is x of 2? It is 2. So 11 plus 2, which is 13. Similarly with the remaining, and you will get the desired value of s. Next is using for loops. Find the sum of the two vectors entered by the user. When you have two vectors, you have to make sure that they are having the same number of elements. So we use the conditional statement if. If n is not equal to n1, where n1 and n are the length of the vectors, you display that they don't have the same number of elements. Otherwise, for I equal 1 to n, z of I will be x of I plus y of I, and then end, display z, end. So the first value of I will be 1. So z of 1 will be x of 1 plus y of 1. Similarly, it will continue till I takes the value n, where z of n will be x of n plus y of n. Nested loops. That is when you have a for loop inside another for loop. For I equal 1 to 5, for j equal 1 to I, display j, end, end. What are the values of I and j? So the first value of I is 1. Then j becomes 1 to 1. So when I is 1, j has only a single value, which is 1. So it'll exit that loop. Again, I will change to 2. So j will become 1 till 2. So there are two values that j can take here. So when I is 2, j has two values, which are 1 and 2. When I is 3, j has three values because it goes from 1 till 3. So 1, 2, and 3. Similarly, for 4 and 5. So the total number of times this nested loop executes would be, the outermost for loop executes 5 times, and the innermost for loop would execute a maximum of 5 times. Find the sum of two matrices entered by the user. When you have two matrices and you need to find the sum, you have to first make sure that their sizes are matching, which means the rows numbers should be equal and the column numbers should be equal. So first input the two matrices, then m is equal to size of A and n is equal to size of B. So we are finding the sizes of the two matrices. Then R is m of 1 and C is m of 2. So the number of rows is the first element in m, and C which would be the second element, which is m of 2. Now if m and n are both equal, that means the sizes are equal. For h equal 1 to r, which is the row number, and for k equal 1 to c, which is the column number, the new matrix S of h comma k would be A of h comma k plus B of h comma k, and then end the for loop and another for loop. Else display matrix addition is not possible. Then you write end and display S. You could pause the video here for example 5 and try to do it on your own in the MATLAB window. The next example is using a while loop. It's a simple while loop. So x is assigned a value 5, k is assigned a value 0. And is 5 less than 25? It is a true statement. So k will have a value 0 plus 1, which is k is equal to 1. So y of 1 will be 3 times 5, which is 15. Now x value will change to 9 because it is 2 times 5, that is 10 minus 1, 9. Is 9 less than 25? Yes, so k will change to 2. So y of 2 will be 3 times 9, which is 27. And x will change to 2 times 9 minus 1, which is 17. Is 17 less than 25? Yes, so k will change to 3. So y of 3 will be 51. Now x becomes 33. So is 33 less than 25? No. So the loop will exit at that point. So y of 3 is printed as 51. We'll have just 3 values displayed here. That is for y of 1, y of 2 and y of 3. Next, write a script file to determine how many terms are required for the sum of the series 5k square minus 2k, where k is starting at 1, to exceed 10,000. What is the sum for this many terms? So initialize the total to 0 and k, let's make it start at 0, while the total is less than 10 to the 4. K should always increment itself, so k becomes k plus 1. Total is given as 5k square minus 2k plus total and end. Then we can use the display to display the number of terms and the sum. So when we run this program, we get that the sum is 10,203 after 18 terms. Next is again an example using while loop. For the given series, find the number of terms needed to get the sum corrected to 2 decimal places. So the x value, you can make it user specific. Initialize the n value to 1 and s value to 1. We are doing that because when k is equal to 0, the first term is 1. So initialize the sum to 1. Error is exp of x minus s over exp of x. Now while the absolute value of error is greater than or equal to 0.01 and the number of terms n is less than or equal to 30, you calculate the term an, which is x to the n over factorial of n, and s will be s plus an, and after that increment n, so n will become n plus 1. Calculate the error using the formula and then end. So if n is greater than or equal to 30, display more than 30 terms are needed and then end. fprintf, the approximate of the exp and then the number that you've put would be %f, so that will be corrected to 6 decimal places, and fprintf, the number of terms used. To stop an indefinite loop, press Ctrl C or Ctrl break keys. This is an example of an indefinite loop. X is assigned a value 0.5. While x is greater than 0.2, x becomes twice x. So the first value of x is 0.5, it's greater. So x will become 2 times 0.5, which is 1. Again, 1 is greater than 0.2, so x will become 2 times 1, 2. 2 is greater than 0.2. So it will execute infinite number of times. So to exit from such a situation, you can press Ctrl C or Ctrl break keys. Let's work on some problems from the textbook. First one, use loops to create a 4x3 matrix in which the value of each element is the sum of its row number and its column number divided by the square of its column number. So we have the number of rows as 4 and number of columns as 3. We need a 4x3 matrix. So for I equals starting at 1 till r, and for j equals starting at 1 till c. Let's call the matrix as A. Any element would be called A of I, j. So this would equal I plus j divided by the square of its column number. This column number is denoted using j, so j square. And make sure you put a semicolon and then end this inner for loop and end the outer for loop and display A. Let's run this. So you get the desired matrix. But notice that in the command window, the loops keep repeating itself. So to avoid that, we can switch echo off before any for loop, conditional statements, etc. So now if we run this, it's a very clean program. So this was question number 1. Moving on. Question 2, we switch the echo back on. We have to plot a piecewise continuous function. So initialize the x using linspace. As you can see, x is going from -1 to 4. You can define f using the anonymous function. So f is the name of the function. At the rate symbol, the input is just in terms of x. Now to write the piecewise continuous function, let's check the first part, that is, it has a value 20 if x is less than or equal to -1. So put in 20, multiply it with x less than or equal to -1 plus condition 2 dot star the condition which is x is between -1 and 1, where positive 1 is inclusive. Similarly, the third, fourth and fifth. What happens here is when the first value, let's say -1, comes in, it holds good only for the first part. -1 is less than or equal to -1. So the function has a value 20. Whereas for the remaining part, the conditions evaluate as 0 because of the AND connecting them, and f of -1 would have a value 20. But if we have a value that falls between, let's say, -1 and 1, so for example 0.5, so is 0.5 less than or equal to -1? No. So that part will be evaluating to 0. Is 0.5 between these, -1 and +1? Yes. So -10 will be multiplied with 0.5 and then added with 10. So that will be the value of f of 0.5. And the remaining part of the function will be always 0. So for point by point, we'll be generating every point for this plot. So plot x comma f of x. Let's run this. And this is the piecewise continuous function. You can put the grid on, x label, y label, etc. Next question. Write a program in a script file that finds the smallest odd integer divisible by 11 and whose square root is greater than 132. So this is question 3. Let's make a quick comment here. Square root of this number is greater than 132, which implies x is greater than 132 square. Let's start by initializing x as 132 square. The program should find the smallest odd integer that is divisible by 11 and whose square root is greater than 132. So if remainder of x comma 11 double equals 0 and whose square root is greater, so square root of x is greater square root of x is greater than 132, and should also be an odd integer. So how do you verify if it is odd? So you have and remainder of x comma 2 is not equal to 0. Display x, break, and then end. Let's run this and see. And display x. So here actually we need to increment this every time, so x plus 1. So we get the x value as 17,424. Let's work on question 4. A vector is given by x equals from negative 3.5 till 2.5, and let's check if there is a pattern. Negative 3.5 and then negative 5, 6.2, 11, etc. So there is no pattern. We have to input it as it's given. So x is negative 3.5, negative 5, 6.2, 11, 0, 8.1, negative 9, 0, 3, negative 1, and 2.5. Using conditional statements and loops, write a program that creates two vectors from x. One, call it as p, which contains the positive elements of x, and the second one, call it as n, which contains the negative elements of x. In both p and n, the elements are in the same order as in x. So in order to execute these conditions, first of all you have to find how many elements are there in this vector. So we'll use the length command, length of x. Now let's define two new vectors here which are empty. P for the positive elements and n for the negative elements. Now we can use the for loop where the counter I starts from 1 and goes till n at increments of 1. So 1 colon n. Now we have to check for the condition. The condition is if it is a positive number, that is case 1. So if x of I, this is how you address any element in x. So if x of I is greater than or equal to 0, the p will be appended. So it will become p, which is the original, and then x of I. Else, the condition is already understood, so you don't have to write x of I less than 0. N becomes n x of I. And then end for the if structure and end for the for structure. And you can display finally what is your p and n. Let's run this and see. So here we see that we're getting the positive elements as well as the negative elements in two different vectors. And this display command comes up here in the command window. So to avoid all that, we have to switch echo off, and even the loops, how many ever repetitions are there. So all this need not be displayed. So we can switch echo off before the loop. If you run this again, you get a better result. Question 5. Write a program in a script file that calculates the cost of a telephone call according to the following price schedule. There's time the call made, which is day, evening, and night, and the duration of the call, which is divided into 3 sections. For the first 10 minutes, if it's during day, it is 0.10 per minute. From 10 to 30 minutes, it's $1, which is a fixed cost, and 0.08 per minute for the additional minutes above 10. And if it's more than 30 minutes, it will be 2.60 per, which is the fixed cost, and 0.06 per minute for additional minutes above 30. Similarly, for evening and night, we have different costs. The program asks the user to enter the time that call is made, that is day, evening, or night. So we have to use the input command, enter day, evening, or night. And these are the options, which are strings. So you have to use S within single quotes. The next, enter the duration of the call, which is D equals input duration of the call in minutes, and then take the seal of that so that it will round off. The program then displays the cost of the call. So run the program 3 times for the following calls: 8.3 minutes at 1:32 p.m., which would be during the night shift, or the day shift. It would be during the day shift, which is 1:32 p.m. So we have various cases to consider, for which we'll use the switch structure. Switch T. And case 1 will be when it is day. If D is less than or equal to 10, means D is within 1 to 10 minutes, the cost is D multiplied with $0.1 per minute. Else if D is less than or equal to 30 and D is greater than 10, the cost will be $1, which is a fixed cost, plus the difference, which is D minus 10 minutes, the additional minutes above 10. So it is D minus 10 multiplied with 0.08. And finally, the cost will be 2.6, which is the fixed cost, plus the difference, which is additionally more than 30 minutes, so D minus 30 multiplied with 0.06. And then end. Now the next case would be when it is in the evening. So we can in fact copy the same thing and make the necessary changes. So the next case is when it is in the evening. the spellings have to match as given in the choice for the input command. And if d is less than or equal to 10, the cost is d times 0.07. And if it is between 30 minutes and 10 minutes, it'll be 0.7, which is the fixed cost, plus 0.05. times the difference. And the last case is when it is 1.7, which is a fixed cost, and the difference multiplied with 0.04. And finally, when it is the night. So you change the case to night. The cost would be, when it is less than 10 minutes, 0.04 per minute. So see the error there? That means I've made some mistake. So change that. Then cost will be 0.4, which is the fixed cost if it is between less than or equal to 30 and greater than 10. So 0.4 plus the difference multiplied with 0.03. And finally, it is 1 with the difference multiplied with 0.02. And we have to close off the switch with the end again. And we can use the fprintf command to print the cost. The cost of the call is %5.2f \n, and the value lies in cost. Let's make sure that the echo is switched off right from the beginning, and just run question 5 alone. So it's waiting for input. Enter the duration of the call. Let's say it was 7 minutes. So you get the cost as 0.70. And now there's a spelling mistake here, so you can go up and change that. Enter the duration of the call. So that's how you do question number 5. Now let's just comment this question. You could try the different values. Question 6. Create a 100 element vector containing the values 1, 2 to 100. So let's create the vector first. It's from 1 till 100. Then take the square root of all elements whose value is greater than 30 and divisible by 3 or 5 using a for loop and if construct. So first we know that there are 100 elements. So for I equal 1 to 100, if x of I, you have to take the square root only if the element has a value greater than 30. So check if it is greater than 30 and divisible by 3 or 5. So to check divisibility, we can use the mode or the remainder command. So mode of x of I, comma 3 double equal 0, or so use straight line, mode of x of I, comma 5 double equal 0. Now these reddish lines indicate there is an error, so let's correct that. Mode of x of I, comma 5 double equal 0. And close the bracket for the OR. Okay, now if it satisfies that condition, x of I will become square root of x of I. Else x of I will remain x of I. So end the if structure and the for, and display x. So here there's a reddish line, so let's correct that with an extra bracket there. Here it is mode of x of I, comma 5. You can try running this program. So it takes the square root wherever the condition is satisfied. Question 7. The factorial n of a positive integer is defined by this n factorial, where 0 factorial is 1. Write a function that calculates the factorial n of a number. The function displays a message if a negative or non-integer number is entered when the function is called. Compare your result with the command factorial. So we're just writing this in a script file here. N equal input, enter a non-negative integer. If n is less than 0 or floor of n is not equal to n, so we are checking if it is an integer or not. Display error. Else, for I equal 1 to n, p is initialized to a value 1, and then p becomes p times I, and then end the for loop and end the if structure, and then display p. Now what will happen if I choose I as 1? P is equal to 1, so p changes to 1 times 1, which is p has again a value 1. I increments to 2. Again p is redefined to 1. So the change in p is not being allowed to happen. So we have to define this outside the for loop, so that each time the p value will be changed. Now p is 1, first value of I is 1, so p becomes 1 times 1, 1. Next I becomes 2, so p becomes 1 times 2. Similarly it will go on till it reaches n. And then end the for loop, end the if structure, if construct, and display p. Now let's run this for 6. So we get the factorial as 720. But what if we enter a negative integer? Let's enter. You get the error as 1. Why does this 1 come here? You're supposed to get only error as the final output. It happens because p is assigned a value 1 right here, and once it displays error, p still has a value 1. So it displays the latest value of p here. So to avoid that, we should display p right after the for loop. So if we run this, for a -5, you get the output as error because it is in negative integer. And whereas if we run it for 5, we get the output as 120, which is a factorial of 5. That's all for now. Thank you.